Hello everyone, I am Davronbek Malikov from Kansal National University, Department of AI Convergence Engineering. Now I'm going to start my presentation under title of Machine Learning Based XG Forecasting in the Top Soccer Leagues, a Comparative Analysis. Then let's get started. Let's first, this is my table of contents, which I'm going to explain using these contents. First of all, I will start with background information in this area and also research problem and overview. And I will introduce my dataset and explanation of some methods for this research and also result and discussion. And I will finalize my presentation with conclusion and future work. As we know that nowadays soccer is one of the popular game. This reason that it's called millions of game. I can see that it is not millions, it is billions of game. It's the most popular game in the world. So due to lots of and due to hard competition nowadays, soccer clubs trying to use some analytics, some using data analytics especially. By the help of data analytics and machine learning, AI, and nowadays soccer clubs are competing each other. We can say that data analytics nowadays is kind of assistant of coach even in the modern football. By helping data analytics nowadays, the soccer team can predict the player potential and output. It means how much that particular player can contribute to the overall team performance. Due to this fact that even the coaches can decide and who especially can be selected out of, for example, 30 player and even in the single game will be only 12 player. So, I mean, nowadays the data analytics and machine learning helps great role. And in the next page, I will show you how the particular that metric can evaluate the overall performance in the data analytics. It means that we should have some kind of number. As kind of number, for example, if this number is higher, then we can see that this particular player can produce more. It is kind of logical correct things. Okay, so it is called expected goals. In most cases, that people use XG as an abbreviation. This is one of the key performance metrics in the area. So let's see as a formal definition. Formal definition is that expected goals is statistical measure. Is predicting and it is predicting the estimated likelihood of shooting result in a goal based on shoot quality. For example, expected goals can estimate either this shoot will go or will not be go. This is kind of metric. So I made a one figure. You can see in the right side this figure. So you can see there are lots of value related to expected goals. So that value is how far off the goalkeeper the expected goals will be lower. If near the goalkeeper is that expected goals will be higher. So you can see there are lots of value. There are lots of different value. And another thing that expected goals in the scale can be between 0 and 1. 0 means no chance of scoring. 1 is guaranteed goal. And in most cases, expected goal in between. For example, 0.5, 0.3, like this. But in the one game, these expected goals can be reached 1. Means can be higher than 1. Why? Because, for example, in the team, if the player A make 0.5 and player B 0.9 and player C 0.3 and total expected goal for team will be 1.7. So in our case, each player's expected goals is sum of XG values for their shoots in the game, in the particular game. So by using expected goals nowadays, data analytics that analyzing and assessing the players, how particular player contributing to the team. This is one of the important metric in the area. For predicting expected goals, that people that using there are different types of features. Like for example, number of games. We know that number of games is very important. If number of game is higher, logically expected goals, that player expected goals can be higher, right? It is logically true. And for example, let's pick up yellow card and red cards. On the other hand, if this number is higher, it means that people in the particular game may miss especially game, right? For example, in the red card, the player will be eliminated. His expected goals will be lower, right? So this is also one of the important factors. So in the table, you can see that all of some of examples of the most important features for predicting expected goals. So far, there are lots of work have done by the researchers. So in the table, you could see there are different types of most of related to my work. So this is what I collected and I made this table. So in case of that summary, we can see that lots of work used should-based features for predicting expected goals. Should-based features, that means location, type, distance, angle, this kind of features. And also, they applied some kind of standard algorithms, standard supervised machine learning algorithms like logistic regression, tree-based models. But one of the problem is that they didn't select this kind of features as using some kind of technique. Instead, they use it randomly select. Another part, they didn't use this kind of important features like coaching tactic is dynamic for factors. The coach is very important features that I will show in the later pages, how they're affecting to overall performance of the player expected goals. So, but they are missing. It is kind of a huge gap. So due to this related work, I made that problem which I tried to solve in this paper. Yeah. The problem is limited use of key metrics for predicting expected goals. So, for example, in the previous slide also, you could see that there are some of features that are widely used as called standard features, right? For example, the number of shoots, penalty shoots, number of minutes, number of assists, this kind of features, I think standard features. This also, okay, but the problem is only solely based on standard features, I think, is it not fully capture predicting expected goals. There is a gap. What is gap? Gap is missing some of features for predicting accurately expected goals, right? You have to consider this word accurately. So this is my research overview and goals. Research overview. In the research, I applied supervised machine learning, and I tried to use some kind of constructed features. I invite some of features which are important for predicting expected goals, and my main aim for improving expected goals and also improving the accuracy expected goals for prediction with the help of new features. So my dataset, I used three data sources, FBref, StatisBomb, and Transfer Market. And also I applied it to five European leagues datasets, and that scope is the season is 2020 and 2021. In the table, you could see some of example of my dataset. Okay, so let's move on to new features part. This is data collected as kind of previously collected data. And also, I'm trying to explain some of new features. I'm trying to invent it. For example, the coach's average work. If the coach's average work in the particular team is higher, it means that expected goals also can be higher. Why? Because if coach work 1 year in a team, I think he will not have enough time for spreading on idea, right? So that's the reason that I applied that average coaching average team, average year. And also the tactic also is important, right? For example, that if his tactic is more attacking tactic, so right, it means that the expected goals can be higher. But if it is more defensive, like for example 4-5-1 or 5-4-5-4-1, this kind of defensive, then expected goals should be higher. So what I want to say that this feature also very important for predicting expected goals that previously work have not considered. And in order to constructing features, I applied for new features. And second way is heat map based feature extraction, because I have lots of feature. So in order to selecting some features, I applied heat map based feature extraction method. So I applied threshold 0.5 threshold, and based on this threshold, I narrowed some features. So 24 features selected by using heat map features. So and this is table. In the table, some of features that I use it for prediction, for training, and for result section. So, and then the next part is data pre-processing part. Data must be clean, and also that computer should understand. This reason that I applied some kind of methods. And first of all, handling missing value. For handling missing value, I applied mean for numerical value. If I have some missing values, and for mode is categorical value. So I applied it. And also for converting categorical to numerical, I applied label encoding. Label encoding also very important. So that's reason that I applied label encoding. And in case of feature scaling, I applied min-max scaling. Min-max scaling because it converts that big number, let's say is large amount of number, in the scale of 0 and 1 interval, right? It will not go to negative like standard scaling or robust scaling. This reason I use it min-max scaling. Okay, let's move on to the methods I applied. So you could see this is my overall workflow from data collection to result section. So by using this workflow, you could understand overall workflow of my work. So another part is my objective is that predicting expected goals with constructor features. With constructor features means my new features and features that I extracted using heatmap. And also another difference of my work with previous works, I didn't select some of algorithm randomly. Instead of, I used 5 algorithms and I compared it. Why different algorithm? Because I think we don't know, right? We know that we have data set. We don't know which algorithm is best, either linearly or complex. This reason it is better practice is compare all of them with the same dataset. How they behave in the same dataset. This reason that I used 5. It is very good for maybe ensuring which algorithm is better, because I will use this kind of algorithm later. So for prediction and for result section, this reason. Okay, you could see the comparative evaluation part. Okay, you could see this is in the table. I made this table. This is new features without and with new features. It means with new feature. It means constructed features, right? So you could see in the table there is a maybe increasing part. For example, in case of lasso regression, you see the without new features are to 94, now 93. It means 2% is a normal cases, and also errors also is decreased up to this. So, and also in our case, you could see, and I highlighted it, lasso regression is the best algorithm in my model for my dataset. So, and the further I use in the later part, I can use lasso regression as my main algorithm. Right? In our case, I didn't choose randomly. I used comparative evaluation, and all algorithm shows own result, and I pick whichever is best, right? So that's the reason lasso regression is this algorithm. So I got 2 results. First of all, Liga level expected goals, right? So in our cases, Bundesliga is average expected goals almost 2. This is higher, and La Liga is lower. You can see that there are some of reason, right? So Bundesliga is this, and also my second result with the player base, right? In the top 5 player, you could see from Robert Lewandowski to Harry Kane. So and in these cases, I didn't choose some kind of I didn't choose expected goals as average in case of average in this part, but it is not kind of average. It means total average, total expected goals is in the one season. In the one season, not full their career, right? So for in the result one and result two, right? We can consider in together why Bundesliga is higher Liga, because in the Bundesliga there are lots of top higher players in the season. For example, let's say Robert Lewandowski at the time was playing in the Bayern Munich, right? The Bayern Munich top team of the Bundesliga. This reason that overall Bundesliga result was higher than others. For this reason. But I have some limitation also. Let's move on some limitation. Due to some less data sets, so I couldn't show my own ability. So my data set scope is small for the reason. And secondly, I couldn't find some kind of features. Especially, it means that I couldn't find some kind of matching features like player injuries or other detailed statistics. This is also limitation of my work. So in the future work, I want to increase my dataset. I want to increase the scope of my dataset, and not only top five league, I will extend to another league also. And also, I'm going to implement time series and deep learning models also for training complex datasets also. So this is my future work. And but in that case also, even though I couldn't use good dataset, but I got some results, right? For example, I made model in the top five leagues and for implementing constructed features. And by the help of constructed features, my model increased up to 96%. So by the help of my work, that clubs can use some kind of that feature player selection is for scouting and also for decision making, which particular player can be selected. For example, the team need more goal, then this player can be selected as a Robert Lewandowski players who have more expected goals. Like this is my practical side of my book. So that's all. Thank you for your listening. Thank you for your time. Okay.